Then we need to start working on policy for our devices. So first things first, under administration and network devices, we can see we don't have any. We need to tell ISE that it should expect authentication coming from our switch. And when it gets those requests from the switch, the key, the radius key, needs to match. So because we set up our switch first, at this point, if I was to go look, and if I was a guessing man here, or a betting man, yeah, we're seeing denied requests in our live log. And if we look at one of those, it says request dropped, could not locate network device or AAA client. So we can tell our switch 50.10, if you recall, in the config, we set our radius source interface to 10.1, and we're receiving radius requests from that switch, but obviously we don't have that switch set up as a network device, so we need to do that. So in here we're going to add, name is going to be office_switch, IP. Now notice here, we can set network devices not by just a single IP, but by subnet. This kind of comes in handy a lot when using things like Meraki access points, where each access point is the authenticator. If I put all of those devices on one network, they're obviously going to use the same key, etc. I could call this, Office Meraki access points and make this a WAC24, and all of those access points will be able to authenticate. Device profile, we've got a whole bunch of different profiles. Just tells the ISE here, what to expect coming from the device. We can put in model names, we can put in software version info, locations, etc. None of this really matters to me in such a small environment here. But down here, I need to set my radius shared secret. And that was my password that got plugged in with the radius servers on the switch. And in this case, I'm also going to add my 2C credentials, and my community here is also password. We'll submit that. Now we have our device created. So we're able to accept authentication requests from the device now, but our policy is all still default. If I look at the live logs, now we can start to see that, hey, we're hitting the default policy and getting the default authorization from whatever is trying to authenticate here from the switch. If I go into my policy sets, we can see the only one that exists is default. If we look inside default, we can see we've got wired MAB, wireless MAB, authentication policies, .1x authentication policies, and down below here they've got a slew of built-in authorization policies by default, but we were hitting this default, as we saw, which is a deny access. So we need to build out a policy set for our devices. Once environments start getting bigger, obviously it makes sense to take into account what policy sets do what. And from my perspective, there's a lot of different ways and methodology around how to structure policy sets depending on how you're using ISE. For the sake of the lab here, it's going to be pretty straightforward. I am going to say wired. And in here, I'm going to say this can be wired MAB, or it can be wired 802.1x. We're going to use the default network access. I'll save that. Now in here, we can see we've only got one authentication policy. We need to create, we'll call this one .1x, where this is .1x. If it's .1x, I want to send it to Active Directory for authentication. We'll call this one MAB. Seems a little redundant, but wired MAB here. This one's going to go to internal endpoints, and if the user's not found, we want to continue. So this section of options here, right, with MAB, all we're getting is a MAC address for the authentication from the switch. And chances are that MAC address is not going to be listed in any identity store, let alone the internal endpoints. And at that point, we're not going to find the user. If we reject it right there, it's a hard stop. It's done. MAB is never going to work. So in this case, we set it to continue so that we move down to our authorization policy. Save that. So we've got .1x and we've got MAB. Now this is going to handle EAP-TLS, PEEP, MS-CHAP, any of those, right? And it's going to send it to Active Directory. In this scenario, I want another one for EAP-TLS, and in this scenario, it is going to be EAP-TLS. I am going to send it to my NetTech cert profile that we created earlier. And we'll save that. That takes care of the authentication side of things that we need for this deployment. And if we go back now and look at the policy sets, we've got one set. Anything that comes in wired MAB or .1x should hit this policy. Then it's going to break out and say, okay, for authentication, did the device request MAB or did the device not request authentication, and should we treat them as MAB? Did the device attempt to do EAP-TLS or any other .1x? And this is how we're going to handle the authentication side. Now on the authorization side, we need to respond to successful authentications with some sort of authorization. And this is where we can get into how are we handling these clients. Do we put them in a new VLAN? Do we apply an access control list? What all do we do with these clients as they come online? These rules here will have results that tell the switch what to do with the client. So in order to have those results, we obviously have to go and create them. So underneath policy, policy elements, results, authorization, authorization profiles. So here we can see the ones that are built in. We also have the ability to create our downloadable ACLs. And one thing I believe I mentioned earlier was that we do indeed have to make sure that we send successful authentications to MAB clients. We don't have to do anything with those clients, but we certainly have to make sure that we get an auth accept sent to the switch so that the switch will send that radius information to ISE so that it can profile the clients. So I'm going to create a downloadable ACL that simply denies everything, and all it's going to say is deny IP any, which of course it would hit anyway. I'll call it the profile ACL. Down here, when you're doing these, you can check to make sure your syntax is all correct. So this is going to deny all traffic going anywhere. In my profiles, I'm going to create one called profiling. This is going to be the result that I return to those MAB clients. It has to be accessed except, in my case, the DACL is going to be the profile ACL that allows nothing, and put it into VLAN 7. Now, we haven't talked about the VLANs on my switch yet, but I'll submit that and have it done. So if we jump over to our switch, we do a show VLAN. Right now today, we've still only got these VLANs, but what you'll notice is oops, I want to do 36 for fun here. In my config, that was part of my templates, I set the switch port access VLAN to 7 and my voice VLAN 3. I just didn't create these VLANs or anything while we did the config. So if I go here, I'm going to create my client VLANs. And to talk about these, VLAN 2 is going to be PCs and users. 3 is my phone and voice. That matches up with my voice VLAN. 4, wireless access points. 5, printers. 6 is critical. 7 is a black hole. So what we'll notice here, when I create my SVIs, because again I'm using a collapsed core here, I created all of these interfaces 2 through 6 with a SVI, default gateway, and their helper address pointing to my domain controller for DHCP. And now anybody who gets put in these VLANs successfully authenticated should get an IP. However, with this initial MAB policy that we created, when a user connects, they're going to not only get denied access to the network via the ACL, but they're also getting dropped into a VLAN that literally doesn't go anywhere, right? VLAN 7 doesn't have an SVI. It exists local to the switch. I have no need to trunk it anywhere. It's meant to simply be, you don't get to go anywhere. So now if I exit out of here, whoops, and I look, all of these new networks are up. In VLAN 6 being critical, so if I look at the service template I created, we can see that this critical access VLAN will come into play when our AAA server may be down. So it hopefully won't get a lot of use, but it's there. So I'll go ahead and write this config. And now we'll head back over here to ISE. As you can see, our profiling was created. It is targeting the profile ACL and dropping clients into VLAN 7. We're going to need to create a few more of these. I'm going to create one for printers. I'm not going to worry about an ACL here, but we will put printers into VLAN, what did I say, 5. Submit that. PC user. VLAN 2. One for my phones and voice. And in this case, I don't need to set a VLAN ID because the switch itself is going to set that voice VLAN for me. But I do need to allow voice domain permission. Wireless APs going to go into VLAN 4. We already did printers. So that takes care of our MAB, well, I shouldn't just say MAB, but our authentication device types and what we want to do with them when they get connected. If we go back over to our policy now, we can start to build out these rules that will use those results. So the first rule I'll put in is that profiling rule. And this is basically going to say, hey, if it came in wired MAB and it got this far, and keep in mind these are processed top down, go ahead and return our profiling, which means access except VLAN 7 and the ACL that denies it from going anywhere. Here we'll say printers, and again the process flow for a printer, assuming MAB, would be that it would come in, it would hit this profiling, we would identify in the background the type of printer it was or whatever it might be, and return a COA to the device, which would cause it to then come back and re-authenticate through the list. Now we know what it is. Based on this condition and knowing what it is, what are we going to do with it? So here we will say printers, and in this case there's going to be a million different ways to do this. I'm going to go ahead and say identity group name. And then in the list here, you can see there's a whole bunch of different auto-created endpoint identity groups that we can choose from. Now, one of them is not the printers that I want. So I'm going to have to go create that. For right now, I'm just going to throw this into profiled so that I don't lose my rule here and have to delete it. But we can see now it says, hey, if it's a profiled device, send it to printers. Obviously, that would send a lot of devices to printers that clearly don't need to be there. So if we go to our work centers profiling policy, logical profiles, we can see that there's a whole bunch of profiles here, one of them being printers, and it lists a whole bunch of different types of printers. However, I happen to know that my printer gets found as this HP LaserJet. Now, I'm not really sure why they don't have some of these HP printers in here. I mean, they've got a whole bunch of them, very specific to names, but the HP LaserJet printer as itself, it's a really old printer. So, you know, in your environment, you would have to identify what types of printers. But in my case, I'm going to add this. And then we will go back here to our policy sets, and we can edit this. And I'm going to change this all together to endpoints. Logical profile is going to be printers. So we saw the list of printers. We added my HP LaserJet basic to this, and we'll say use and save. Gonna duplicate above, call this phones, change this to IP phones, and change this to phones. Where did I create that? Phones voice, that's mine. I wouldn't have to save this between all of these. I can do more than one. So now, what am I missing? Wireless APs. Oops, I didn't copy it. Let's delete that. Duplicate above. What we'll notice here is there isn't one for wireless access points. So again, there's a million different ways that we can choose to use these profile devices. In my case, I'm just going to go create one for this. I'll say uses medical devices now. Just save that so I don't have to delete it. Under profiling, call this access points. And here we've got all of the Cisco access points. I'm going to be a little more specific here. I'm going to say 9120s, 4800, and 3800. And we'll change this to Cisco APs. Back to my policy set. Here's our Cisco APs. Wireless APs. So the only thing we haven't taken care of here is our users, PCs. So for those, we are going to create a new one, and I'm going to call this domain computers. And over here, we're going to look to Active Directory for our domain computers and return our PC user. Then I'm going to duplicate that above. And we're going to change this to our domain users. And I'm going to leave the results the same, right? They're going to VLAN 2 either way. Why would we want to do both of these? Well, really what it comes down to is when Windows boots up and gets connected to the network, before the user logs in a scenario like this, they have no way of getting on the network. So the goal of the domain computers is, hey, when a computer's sitting at the login screen, it's got a certificate, a local machine cert, that it can use to authenticate to the network. This helps with things like Windows updates being pushed overnight, that sort of stuff, where when the user logs off, they don't lose access to the network, or if they reboot their computer and it comes up. It helps with, obviously, with Windows logons, making sure that that machine is connected so that they can reach a domain controller and get logged in, that sort of stuff. You could certainly change this result to say, hey, if it's sitting at a login screen, it only gets access to our SCCM server, domain controllers, whatever. If it's only computer authenticated, insert any number of scenarios here that you could use that for. But at the end of the day, I like to make sure that I've got computer-based authentication for machines that aren't logged in, and user authentication for when they do log in. So I've saved that, and that really builds out our policy here and puts us in a position where we can start to test. I'll start going through all of these from a MAB perspective, right? Those devices that aren't going to be doing .1x authentication, and we'll look at what ISE learns, how it handles them, etc.